Alright guys, so today we're going to talk about the triangle sum theorem, which is the interior angles of a triangle. We're also going to talk about exterior angles, and then we're going to talk about the triangle inequality theorem. So first of all, the triangle angle sum theorem is fairly simple. It just states that the sum of the measures of the interior angles of a triangle is always 180 degrees. And again, remember, interior just means inside. So in this image we have here, it says triangle ABC. We have the measure of angle A plus the measure of angle B plus the measure of angle C will be equal to 180 degrees. We also have an exterior angle theorem. First off, the definition of an exterior angle is going to be formed by extending any side of the triangle. So if you notice in this picture here, from the angle goes straight out. Okay, the line goes straight out. And exterior, of course, just means outside. An exterior angle is always equal to the sum of the two non-adjacent interior angles. So what this is saying is that the exterior angle is equal to the sum of the two angles that do not touch. So these are not touching. You may also hear this called remote exterior or remote angles. So in this case, we have the measure of angle 2 and the measure of angle 3 will give us the measure of angle 1. So measure angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Now the reason for that is, if I take angle 1 and this angle here, that is on the inside, those would add up to 180 degrees. And then the interior angles of a triangle add up to 180 degrees. So if the yellow angle here plus angle 1 is 180 degrees, then the yellow angle and plus the 2 and the 3 are 180 degrees. Remember, this is going to be our transitive property. If A is equal to B and B is equal to C, then A is equal to C. All right, so let's do a little bit of practice. We're going to find the missing angle measures using the interior angle sum theorem. So we have an angle here of 24 degrees, an angle of 37 degrees, and it asks us to find the measure of angle 1. Well, the measure of angle 1 is going to be equal to 180 minus the other two angles, or we can say that the measure of angle 1 plus 24 plus 37 is equal to 180. So it'll depend on how you want to do that. If you do it this way, though, you would need to combine like terms. So we would have the measure of angle 1 plus 24 plus 37 is going to be 61. And then I'm going to subtract 61 from both sides. And that's going to leave me with the measure of angle 1 being equal to 119 degrees. And then I'm going to put that right here. You don't have to put it in both locations. Just one is fine. All right. Next one. Now we have a remote exterior angle. Remember, it's going to be equal to the sum of the interior angles. So in this case, we're going to say that the measure of angle 1 is going to be equal to 76 plus 52. And 76 plus 52 is 128. And remember, we're going to use degrees because that is our unit of measure here. Moving on, this one we have a lot of information here. So first of all, we have a right angle. So we know this one is 90. We know remote exteriors are equal to the sum of the interior angles. So that could tell us that this angle right here, outside, is equal to this angle and this angle, but that's not going to be particularly useful. But one piece of information we do have, and is something we should remember, is that this angle here, the 61-degree angle, and angle 2 are vertical angles. And remember from our previous unit, vertical angles are always congruent. So that tells me that angle 2 is 61 degrees. And with that, we have enough information to solve for both angle 1 and angle 3. So to solve for angle 1, that one we already had enough information for. We know that the measure of angle 1 added to the 68 degree angle and the 61 degree angle is going to be equal to 180 degrees. Well, combine like terms, we have 68 plus 61, and that is going to be 129. So the measure of angle 1 added to 129 is going to be equal to 180. So then I'm going to go ahead and subtract 129 from both sides, and that is going to leave me with a measure of angle 1 of 51 degrees. For angle 3, we're going to add angle 2 and the right angle. So we have the measure of angle 3 plus the 90 degrees plus the 61 degrees that is angle 2 will be 180 degrees. And then again, combine like terms. So the measure of angle 3 added to 151 is going to be equal to 180. From there, we're going to go ahead and subtract 151 from both sides. And that leaves me with a measure of angle 3 of 29 degrees. On the next problem, we're given at line L is parallel to line M. So the first thing I'm going to do is highlight the two lines that are parallel in one color. And then I'm going to highlight one of the transversals. We have a triangle between these. I'm going to highlight one of the transversals as a yellow line. And then I'm going to do a different color for the other transversal. Now we have enough information here to solve for several of the angles. First of all, that I would go with is angle 3. And that is because angle 3 is a linear pair with the 73 degree angle. So to find the measure of angle 3, I am going to subtract 73 degrees from 180. So 180 minus 73 degrees is going to be 107 degrees. Right? And we also already know the measure of angle 1 because if we look at the blue lines as our parallel lines and the red line as a transversal, we know that angle 1 is 73 degrees because it is an alternate interior angle with the 73 degree angle. So angle 1 is 73 degrees. We can also say that angle 4 is 49 degrees because it is an alternate interior angle with this 49 degree angle that we were given. They are both inside the blue lines and on opposite sides of the yellow line. Angle 5 is a linear pair with angle 4. So again, 180 minus 49, and that is going to be 131. So angle 5, 131 degrees. And finally, angle 2. There are a few different ways we could do it. We could use the fact that angle 1, angle 2, and the 49 degree angle form a line, so they would add up to 180 degrees. We could use the fact that the remote exterior angle of angle 5, which is 131, is equal to the sum of 73 and angle 2. And we can also realize that angle 3 is equal to the sum of angle 2 and the 49 degree angle because they are alternate interior angles, or angle 3 is equal to the sum of angle 2 and 4. So whichever way you would prefer to do that, my personal preference is going to be to take angle 5, which is 131 degrees, and subtract 73 degrees. So if we take the measure of angle 5, which is 131 degrees, and subtract 73, we are going to get 58 degrees. So the measure of angle 2 is 58 degrees. All right, now we're going to use some algebra to find some missing angles. First of all, we're going to look at our picture, triangle DEF, and they gave us expressions for each of the angles. So because the sum of the interior angles of a triangle is 180 degrees, we know that the measure of angle D plus the measure of angle E plus the measure of angle F is going to be 180 degrees. So we're going to substitute in the expressions that we have here for them. So that means we are going to say D, which is 5x minus 2, added to E, which is 9x plus 3, and again added to 11x minus 21, and that will be equal to 180 degrees. Combine like terms. So we have 9 plus 11 is 20, plus 5 is 25, so 25x. Minus 2 and negative 21 is going to be negative 23. Add 3, and that's going to give us negative 20. And that's equal to 180. We are going to add 20 to both sides, which will give us 25x is equal to 200. And then, of course, we will divide both sides by 25, which will give us x equals 8. So then we're going to use that information to determine the measure of angle D, E, and F. So we have D, which is 5x minus 2. 5 times 8 is 40, minus 2 equals 38 degrees. Angle E is 9x plus 3. And so that's going to be 9 times 8 plus 3. 9 times 8 is going to be 72 plus 3 is 75 degrees. And then finally, 11x minus 21. So 11x minus 21. 11 times 8 is 88. Minus 21 is 67. Last problem in this section. We have angle DCB is given to us as 18x minus 15. CAB is 13x minus 11, and ABC is given to us as 4x plus 1. It would like for us to solve for x and then determine all of the angle measures. So of course, first, we are going to solve for x by writing our equation. We have the measure of angle DCB is equal to the measure of CAB plus the measure of angle ABC. So we're just going to substitute in our known values of 18x minus 15 is equal to the sum of 13x minus 11 and 4x plus 1. We need to go ahead and combine like terms. So on the left-hand side here, we're not going to have any changes at this time. But we are going to combine like terms on the left-hand side. So 13x plus 4x is 17x. Negative 11 plus 1 is negative 10. We are going to subtract 17x from both sides, which will leave us with x minus 15 is going to be equal to negative 10. We will then add 15 to both sides, which will give us a final value for x of 5. We'll then use that information to substitute in for each of the angles that were given here. So for a measure of angle CAB, we have 13x minus 11. So it's 13 times 5 is 11. 13 times 5 is 65, minus 11 is 54 degrees. ABC is 4x plus 1. So we have 4x plus 1, which is 4 times 5. Add 1. 4 times 5 is 20, plus 1 is 21. I'm going to do next is DCB. And DCB, again, is equal to the sum of CAB and ABC. So I could do 18 times 5 minus 15, or I could do 54 plus 21, which is going to be equal to 75. And because angle DCB is a linear pair with angle ACB, or we could do it with the interior angle sum. Either way, we're going to take 180 and subtract 75. And we are going to have an angle measure of 105 degrees. Okay, so our next thing we're going to discuss is the triangle inequality theorem, which is relatively simple. The triangle inequality theorem states that a triangle can exist if the sum of the lengths of the two shorter sides is greater than the longest side. So basically it means add the two ones together, the small ones together, and if it's bigger than the last one, then it's going to be a triangle. So let's go ahead and look at some practice with this. So in front of me, you can see that I have 8 pencils of varying lengths. And what I'm going to do is I'm going to demonstrate that if they don't equal more on the third side, then they can't be a triangle. So first of all, I have a pencil with a length of 2 and a pencil with a length of 3. I'm going to go ahead and line those up end to end. And if I take 5, because 3 plus 2 is 5, I can see I cannot actually work a way to all of these pencils come together. So there's no way for me to take this 2-inch pencil and this 3-inch pencil and connect them in such a way that the lead of one touches the eraser of the other, and the eraser of the 5-inch one touches the 2. No matter how I rearrange these, they are never going to be able to touch properly. Okay. Again, I wouldn't be able to do it with the 4 either, because 4 is of course less than 2 plus 3. Look here, 4, I can't connect the tips together. If I put the pencil leads for 3 inches and 4 inches together, there is not a way for me to connect the 2-inch lead and the 2-inch eraser to either of these erasers, or to both of these erasers, no matter how much I rotate it. However, what I can do is take the 6-inch pencil. I can take the 3-inch pencil and the 4-inch pencil, and 3 plus 4 is 7. So I should be able to make a triangle with the 5, the 6, but not the 7. Of course, I know 5 is going to work, because 3, 4, and 5 are what we call a Pythagorean triple. So that means I can make a right triangle out of them. I can connect. I can make the eraser overlap and the pencil lead over. So I can make a triangle with these 3 lengths. So let's go ahead and put this into practice. So we have 8, 17, and 24. We are going to add 8 and 17. 8 plus 17 is 25. Because 25 is greater than 24, and the way we write that to justify as an inequality is simply 25. So 25 is greater than 24, so therefore the answer here is yes, this can be a triangle. Next one, 3, 3, and 7. 3 plus 3 is 6. 6 is less than 7, so therefore the answer is no, because 6 is less than 7. Next one, we have 25, 12, and 35. 12 plus 25 equals 37. And because 37 is greater than 35, we can say yes. So you can see here that I filled in the rest of these. I have 42 plus 37 equals 79. 79 is greater than 52, so yes. This one has 28, 50, and 22. 28 plus 22 equals 50. Because 50 is equal to 50, the answer is no. As you saw when we tried to do 3 plus and 2 and 5. Okay, 3 plus 2 is 5. 5 equals 5, so it doesn't work. 6, 18, and 14. 6 plus 14 is 20. 20 is greater than 18, so the answer is yes. 24, 12, and 11. 11 plus 12 is 23, which is less than 24, so no. And 41, 7, and 35. 35 plus 7 is 42, which is greater than 41, so therefore the answer is yes. Now to find a possible third range side, we're going to use the sum. So the way we're going to do that is just by adding the two numbers together for the sum and subtracting them to get a difference. And that will give us the range for our possible third sides. So we have 22 minus 14 is going to be 8. We have 22 plus 14, which is going to be 36. So that means our side has to be larger than 8 and smaller than 36. So we have 31 minus 28, and that is going to be 3. And then we have 31 plus 28, which is going to be 59. So this triangle can have a third side anywhere from 3 or greater than 3 and less than 59. It's a very large range. 3 and 11. 11 minus 3 is 8. 11 plus 3 is 14. So the range that we're looking for is 8 less than x less than 14. All right, we have 45 minus 19. And that is going to be 26. We have 45 plus 19, and that is going to be 64. So we have our inequality is 26 less than x less than. We have 24 and 7. 24 minus 7 is 17. 24 plus 7 is going to be 31. So our inequality is 17 less than x, which is less than 31. 17 minus 8 is going to be 9. And 17 plus 8 is 25. So 9 less than x less than 25, right? If a triangle has lengths of 15 and 27, it wants us to select all possible lengths for the third side. So again, we have 27 minus 15, which is going to be 12. And then we have 27 plus 15, which is 2. So we are looking for all numbers that are greater than 12 and less than 42. So that means we could have 34, 29, 18, but not 12 and not 43. Same thing here. If a triangle has lengths of 45 and 9, select all possible lengths for the third side. So 45 minus 9 is 36. And 45 plus 9 is 54. So the range that we're looking for is x is going to be greater than 36 and less than 54. So again, we're going to say we can do 47. We can do 39, but we can't do 54, 35, or 58. All right, so the last thing we're going to discuss here is how to use the sides to order the angles of a triangle and how to use the angles to order the sides of the triangle. Now you may notice this is already partially filled out, and that is because I accidentally muted my microphone and I'm now re-recording it. So the parts I added here is that the smallest angle is always opposite the shortest side, and the largest angle is always opposite the longest side. So if we look here at our shortest side, which is 7, we're going to look across from it to get to angle A. So angle A is our smallest or least. We can look at our next smallest side, which is 10 feet, and it is across from angle C. And then finally, our longest side, 13, is across from angle B. So in order, it's angle A, angle C, angle B. And then the converse is true as well. The shortest side is opposite the smallest angle, and the longest side is opposite the largest angle. So we have here across from angle 35, angle F, which is 35 degrees. Again, that is 103 plus 42 is 145. 180 minus 145 is 35. Across from angle F is side DE. And then we have our 42 degree angle as our next smallest angle. So we're going to look across from angle E, which is going to be segment DF. And then, of course, by process of elimination again, we can either see that across from angle D, which is 103, is side length EF, but we can also do that by process of elimination. So we already had DE and DF, so our third side is EF or FE, however you want to put it. All right, so we're going to do some practice problems, and the most important thing here is to realize that they are asking us in the first one from least to greatest, but then it asks us to do greatest to least. So make sure you're paying attention at what you're being asked. All right, so again, we can look across from each of our smallest side. Across from side NP, which is 17 meters, is angle M. Across from side MN, which is 20 meters, is angle P. And across from side MP, which is 24 meters, is angle N. So the correct order of our angles here is angle M, as in Mary, angle P, and then angle N. Number 2, we're going to do the same thing. We're going to look and see that our shortest side is side RS, which is 30 inches. And the angle across from that is angle T. Then we have our next shortest side, which is ST, which is 35 inches. Across from that is angle R. And the last angle is angle S, which is across from RT, which is 38 inches. Moving on, number 3, they want us to do it in the opposite order, greatest to least. So we're going to start with our longest side, which on number 3 is 11 kilometers, or side DB, which means the side opposite that, angle C, is our largest angle. Side CD is 9 kilometers. The side opposite that is 8, is angle B. And finally, our side opposite our smallest, our angle opposite our smallest side of 8 kilometers is angle D. Number 4, we have side lengths of 43, 29, and 26. Across from the side length of 43, which is WY, is going to be angle X. Across from the side length of 29, WX, is angle Y. And finally, across from the shortest side of 26 is angle W. Now for number 3 and 4, we're going to go the opposite direction, but we do need to figure out the third angle in each of these. So what we're going to do is we're going to add the given angles together and subtract from 180. All right, so on number 5, angle K was 92 degrees. So that means our shortest side is KL because it is opposite the 31 degree angle. Our middle side is JK because it is across from 57 degrees. And our longest side is JL because it is across from the 92 degree angle. Looking at the next one, number 6. Our smallest angle is 53 degrees across from angle V, which is the 53 degree angle, is side ST. Angle T is 59 degrees. Across from that side is side S. Across from that angle is side SV. And finally, across from the 68 degree angle, angle S, is side TV. And those ones we were listing again from least to greatest. But now we're going to do greatest to least. So we have number 7, triangle XYZ. Z is our smallest angle, X is our medium angle, and Y is our largest angle. So we're going to start with side across from Y, which is side XZ. Then across from the 54 degree angle, angle X, is side YZ. And finally, across from angle Z is angle YX, or XY, whichever way you want to do it. Finally, number 8, our angles are 90 degrees, 46 degrees, and 44 degrees. Angle D is our 90 degree angle. Across from that is segment BE. Our second largest angle is 46 degrees, angle E. And across from that is side BD. And last but certainly not least, our smallest angle is angle B, 44 degrees. And it's going to be across from side DE. So that's going to wrap up this section of our notes. Make sure you have it completely filled in from the very beginning with classified triangles all the way through to the end of the Triangle Inequality Theorem tab. Stay safe, and I will see you later. Bye.